Welcome to the Crazy Wisdom Podcast. Today, my guest is Yury Selivanov, and he is the CEO and co-founder of EdgeDB. And we're going to get into what exactly EdgeDB is because I have an AI whisperer down here in Buenos Aires who's a senior developer, and he told me that EdgeDB might actually fit into what I want to build. And so welcome to the show, Yury.
Thank you so much for having me.
So what is the 1 to 3 liner for EdgeDB? What does EdgeDB do?
It's essentially a reinvention of relational database from scratch, given modern requirements to application development. We actually want to make databases easier to work with,
Good.
and it's not a big secret in the industry that developers don't really like databases and dealing with them. And one of the reasons for that is that relational databases were invented in the 70s, and most of the decisions for the syntax of the query language, for the data model, how you define your databases, it was defined in that period, and it was never properly challenged. So while the rest of the ecosystem evolved drastically, we have so many different programming languages that didn't exist in the 70s, or even like 20 years since 70s. We haven't seen anything like that happen to the database world. And with EdgeDB, we want to change that.
Nice. Very interesting. Lots of places we can go into that. I've been doing a series with my dad called Stuart Squared. Both of us are named Stuart, and he was in the 1980s kind of figuring this stuff out. So I've talked to him and my uncle recently about, what it was like in that time frame when they were making those decisions. And it's so hard for me to understand being non-technical and then also considering the full history. And it's so interesting that we as human beings just kind of make these decisions that end up sort of defining the future of these things. We can't really see it clearly because we're just kind of tinkering around. Like entrepreneurs are just tinkering around, and they're kind of dealing with the business aspect versus the technical aspect. And then there's a bunch of technical data. But in the software world, it seems so interesting because it's all abstraction. It's not like a physical product. For example, I don't know, it's got to be something like foundational. I mean, the electrical grid is a good example of this, because the electrical grid is like, there have been improvements, but it's like a physical thing that an electrician knows how that thing works. But when you get into software, it's just abstraction, abstraction, abstraction. And the beautiful part about that is somebody like EdgeDB can come in and take another swing at recreating that foundational thing, but you don't have to reinvent all these different layers. You can just create a new abstraction and then allow that. Is that an accurate representation? Any thoughts on what I just said?
Yeah, it's actually quite accurate. And I must say that it never occurred to me that there is some similarity between relational databases and Power Grid. Before I go deeper, I must say that a lot of those decisions that people in the 70s, engineers in the 70s, and computer scientists in the 70s made about relational databases were spot on. I think SQL as a query language and relational databases and relational algebra, they are incredibly solid and powerful concepts. And the reason why I think what we're doing with EdgeDB has never, or never is probably a wrong word, but there is not enough competition in relational database space specifically. Like SQL is the standard that everybody sort of adopts and uses. That is the testament of how powerful it is. That we were able to use it for so long and make it work. So I think we must give credit where it's due. Relational databases are absolutely amazing piece of technology.
Okay, that's really interesting. So let's go into that, because that'll be helpful for my own history investigations. SQL. What is SQL? Why was it important in the 1970s? I'm looking it up right now. Their foundation of SQL and relational databases were laid in 1970 with Edgar Codd, an IBM researcher, and it's a relational model of data for large shared data banks. Yeah, why like the database feels like it's the most abstract of all the abstractions because it's like this huge amounts of data in the background, whereas a front end you can feel it, you can touch it, you can interact with it, whereas a back end it's just totally out there. It's like really difficult to understand. So what problems did SQL solve?
So it wasn't just the SQL. It was
Mm,
also relational algebra. So databases were intensely researched. They're still intensely researched to this
yeah.
day. But back then, essentially, what was happening? Well, it was the beginning of essentially digital revolution. You
Yeah.
had companies that were selling and building mainframes, people writing software, storing data and writing applications around data was absolutely necessary for pretty much anything. For I don't know, aviation companies, the big store chains and banks, all
Mm,
of them wanted to store data, process data, access data, and analyze data as well. And obviously, engineers relatively quickly discovered that we need better abstractions. That reinventing your data store for every application won't scale. One of the useful insights for developing SQL was to make a standardized language essentially so that not only engineers can write code and query the data, but also data analysts could actually exist and query the database and
mm,
analyze it and look at it. So SQL was one of the attempts to actually make data usable for pretty much anybody who has access to the system and knows the language. Also, the relational algebra itself, it basically uh, offered a model for efficiently storing data, for eliminating duplications of data, because they inevitably exist uh, uh, to also sort of concretely define how you define relationships between data, how you traverse those relationships, how you can build reports out of how you can analyze those relationships, how you can compute on top of those relationships. And to this day, relational algebra I think is the best we have
mm.
for describing general purpose data models. Um, so it was a combination of those two.
Brilliant. One question I have in mind that I'll just put out there in case you have a good answer is what were the early relationships? You know, I when I first started learning how to code in 2015, there would be one of the big things I got from that experience, which I was very grateful for, was the one-to-one, one-to-many, many-to-one, and those are all relationships. And an example would be like Facebook, my post goes to many different people, but there's just a whole bunch of different relationships. So I want to understand what were those early relationships in the businesses. You mentioned the banks, these big companies and such. Also, I have a question about how they were doing all of that beforehand, before the computation, before the PC came in, and all of a sudden, I guess it was a long evolution because they had the mainframes, so it wasn't just a direct to a PC. There was a long 20 years of history, 30 years of history that went on before that. And so that's really interesting. Let's go into that. What can you talk more about what are these relationships? Why are they so important? And why did relational algebra, because that's probably it. There's so much data going in that the relational algebra, in the same way that the LLMs today are helping us with vector algebra, with
Mhm.
linear algebra. What's going on there?
So the question about relationships is rather interesting one because it sort of taps into one of the fundamental properties of
Hmm.
relational database. It's the notion that they have actually a schema,
Schema.
and schema is something that defines the data layout. And there is sort of big split in the database world between databases that have a schema and databases that don't have a schema. Databases that have schema, examples of them are SQL databases like Postgres, MySQL, Oracle, I don't know, DB2.
Yeah.
And databases without schema would be MongoDB, CouchDB, or things like Neo4j, which is a pure graph database. And there are certain advantages to both approaches, and there are specific use cases when one approach is might be better than the other. But with relational databases specifically and the SQL, you do have schema. And in your schema, what you're defining essentially is like buckets of data and how those buckets of data can be connected to each other. So for example, you can have a bucket, we'll call it table, a table of users, and users will be authenticated in your system by their email, for example. And then you can, in your schema, you can say, hey, you must not allow two different users to exist in this table with the same email. Emails must be unique. So you can enforce that. And the database itself will enforce the correctness of the statement. Same with relationships. Imagine that you have a user and you also need to store their, I don't know, application preferences, for example. And there is an invariant that there is only one sort of preferences record for the user. So the relationship can be one-to-one and so forth. So yeah, as soon as you start defining schemas in your relational database, you will inevitably sort of learn about those kinds of relationships or different cardinalities of them, and start encoding them into your schema, and then the database will ensure the data consistency for you. And this is one of the other big aspects of relational databases in general, is that they allow you to easily sort of codify those business logic rules, those invariants that must hold all the time. And that sort of lessens the work for you that you have to do in your application code. Because the database handles that for you. But on the other hand, it can backfire because managing a database schema can be painful. This is part of the reason why a lot of people prefer schemaless databases, because you don't have that particular pain, although that pain manifests in different places. It's a complex topic, and I'm happy to dive into it.
Yeah, no, go for it. Go for it.
Just answering your second question, I'm not a computer science historian, so I don't quite know how exactly they were solving all of those different problems in business domains before relational databases. All I know that when relational databases actually happened, it was a big surge. It was pretty much immediately embraced by the industry. People recognized that this is a net improvement. We have to adopt it.
And this is a crazy thing about technology in general, and particularly with software, and particularly with the age of acceleration, and now with AI that we find ourselves in, is that all these pieces, like these were major headaches for people in the 1970s and the 1980s, and now they're just part of the water that we swim in as digital fish. Like it's just part of it, and so we lose gratitude for all these kind of things that are happening now. I have a very good understanding of what databases do and how they can help me, and what I'm getting into with the schema and not having a schema and those choices. Now we're going to fast forward. I mean, there's a lot of things we could talk about in terms of AI and how you guys fit into AI, but I want to understand in that world that you just helped us to navigate, where does EdgeDB fit in? What are the people using EdgeDB to do in terms of that schema, no schema, or all of it together?
So EdgeDB, you can call it SQL 2.0. We can probably say that. We are building on the same foundation, like the same mathematical foundation, and actually under the hood, EdgeDB is built on top of PostgreSQL, which is a popular open source relational database. The problem that we're solving is is how we can improve developer experience with relational databases. And developer experience is a very loaded term, but in general, with relational databases, we say that pretty much every aspect of dealing with them can be improved, from installing, from defining your schema, to querying the database, to integrating your database with your actual backend or front-end code. And I'll elaborate on a few things here. So, for example, with the schema, in classical relational database like PostgreSQL or MySQL or pretty much any of them, you have concept of table, and in this table store data. You have other tables that you can join to your table when you're querying the data, and this works just fine, except that in modern programming languages we don't work with tables at all. This is a very foreign concept to any high-level programming language.
Oh, interesting.
For better or worse, programming languages work with like small buckets of data. We usually call them objects. Some languages call them records. And we basically, when we are writing, I don't know, C++ or Python program, we're thinking about our objects as a graph. So we have this object and that object, and we can traverse sort of all those sort of like object chains by just navigating attributes of those objects. But relational databases are very different. They have tables. So there is a big gap between how data is represented in the database and how data is represented in your programming language of choice, pretty much any one of them. And back then in the 70s, this was probably fine. But with nowadays, it's becoming bigger and bigger problem. This problem is big enough to have like a separate Wikipedia article about it. It's called object relational impedance mismatch. And the industry solution to this problem essentially is to solve this problem on the side. So essentially solve this problem in your software stack. There are lots and lots of libraries that are called ORMs or ORMs, object relational mappers. So what they do, they map your tables to your objects or records. And this mapping is unfortunately very inefficient. Basically, the database itself has a complexity, and then your ORM library also has its own complexity, and those complexities often multiply. And also those ORMs, they are not super efficient at times, or they give you very high level API, and you don't have complete confidence in what actually that API is doing under the hood. Like, will that innocent data API call do just one
mess
query
something up,
database, or will it do 100 queries? You have no idea. So they do solve a big fundamental problem, but they also add friction. And one of our ideas was, well, it's not like a physical law of this universe that those libraries have to exist. The reason why they exist is because the data model of classical relational database is a little bit low level. Can we make it high level? Can we actually solve this problem right in the database itself? So this problem just goes away. So this is number one thing that we did. We basically elevated relational model to higher level of abstraction. Instead of tables, we have high level object types. Everything is strictly typed. Everything is schema defined. But there is no gap anymore in your database and your backend code. Second thing is the query language itself. So SQL, for what it's worth, again, it's a very powerful query language, and there are areas where it's still quite good. For example, data analysts and probably data scientists, they can do a lot with SQL. It's good for generating reports and whatnot. But for building applications with it, it's sort of suboptimal. Things that are natural for programming language, which is working with like this object graph, or which essentially is a data hierarchy, in SQL is very, very hard, because SQL fundamentally is attached to this notion of tables. Essentially, what you're doing ultimately with your SQL query, you're selecting a table. You can join multiple different tables to it. but the data that you are selecting from SQL is still going to be flat.
Yeah.
So you basically have to write a SQL query or generate it with a norm, and then it will return you flat data. And then you need to normalize this flat data back to higher level data model that you have in your programming language. And that is also painful. So our idea was, what if we can advance SQL further? What if we can build a new query language based on many of the principles that SQL has, which is declarative language, high level language, because SQL is still relatively high level. What if we can build a query language, design a query language that would allow you to easily work with hierarchical data, so that the data that you get from your database isn't flat anymore, that it actually returns you a set of objects, and those objects can be nested and whatnot. And while there, we also wanted to make sure that the query language feels modern. There are lots and lots of advancements in computer science and software engineering and whatnot, and I think the bar for a new programming language is way higher than it was in the 70s. When it comes to readability, when it comes to sort of glanceability, can you glance at the screen quickly and understand what this thing is doing? So we wanted our query language, which we call EdgeQL. We wanted it to be easy to pick up, easy to start writing your queries in, to be very high level and hierarchical, but also sort of logical, so that you could precisely understand what it's doing. Again, there are some spiritual parallels with SQL, lots of them, and in fact, at least currently in our stack, what we do, we basically compile our high-level EdgeQL query language to low-level SQL behind the scenes. So basically, treat SQL as machine code or something like that. So we compile high-level query language to low-level query language. But a lot of this magic sort of happens behind the scenes, and as an engineer, you don't really need to think about it. And ultimately, in the future, who knows? Maybe in the future we'll just sort of merge PostgreSQL code base into our code base and just eliminate this step and start sort of generating start evaluating EdgeQL just as PostgreSQL does to SQL. But for now, to sort of lessen the engineering complexity and making sure that we can actually iterate on EdgeDB quick, this is what we do currently.
Very interesting.
So EdgeQL is ultimately very connected to SQL still, but it is a big improvement in terms of readability, in terms of power and expressiveness.
Okay, great. Yeah, this goes in directly into the AI question, the machine learning question. Right. I love what I've learned in the last few weeks is how important this readability part is, because just in terms of, basic getting the HTML, the Python code, and just like looking at a glance to understand what it does. Now I can do that inside of a file. I can understand what it's basically doing. And it reminds me that there's so much of what is going on, which is not necessarily with the machine itself, but how to make the machine easily understandable by the human. I would say maybe it's like 80% of it, because, the machine, like, and then we got the LLM question coming in, which is now we can almost talk directly, like non-technical people can talk directly with the machine in natural language, and it can speak back in a way that they understand. That seems like a really important step. And so within this, I'm going to describe something that I've noticed about the technology in the last couple of years, which is that in order for me to get the LLM to code for me, I no longer need to know how to code. And the main thing I need to know about is like knowing about something like EdgeDB or another of JSON. JSON is the perfect example. JSON is now becoming the language which these LLMs are allowed to speak with. And so OpenAI released their function calling, and that function calling basically requires things to be outputted in JSON. And so JSON is becoming this fundamental piece of technology that that are really important for coding with the LLMs or just getting data from the LLMs. And so there's another example would be Markdown. Markdown is something that's becoming really useful for LLMs in terms of their output, in terms of navigating them, is just like it can bring it out in Markdown, and then Markdown can be taken to other places and used. And so what I would love to understand from you is, how do you see this AI world evolving in terms of, like, there's one question, which is the LLM itself making use of all these different technologies, and like where do we go from here? Then there's the other aspect of AI coding in general, whether you're doing it, whether your team is doing it, and all of those things. Because a lot of, when I tell developers that I'm just getting the AI to code for me, they're like, yeah, you can do that, but you're just gonna have so many different bugs. And at a large application level, that's gonna be a problem. But what do you think about these two questions, about like these foundational pieces of technology that are getting instantiated right now as we speak, where EdgeDB fits into that? I saw you guys did a deal with Vercel, so you're now in Vercel is a perfect example of this, which is that now to deploy it, I can use Vercel. Sometimes it doesn't work, so sometimes I go to Replit. And so let's start with that question about the foundational pieces of technology. Where do we go from here? How do you see what I just said? What's your take on what I just said? Do you agree with it? Do you disagree with it? And you can totally disagree with it. More than happy to kind of get into it.
So this is probably going to be a conversation until the end of this podcast. So, I have a lot of different thoughts. First of all, AI is here to stay. I think it's pretty obvious at this point. Second of all, it's undoubtedly useful for writing code. As you said, I probably wouldn't trust AI to write an embedded system for me or an operating system kernel. I would probably not trust it to write any mission critical C or C++ code or something like that. And I have some thoughts on that as well. Basically, I think that there are two different modes for a software engineer when they one is when they're reading code, and the other is when they're writing code. It's easy to sort of get into a flow of generating low level, some sort of low level code, and not spot mistakes, subtle mistakes, because in a low level language like C, you can have a little thing that will actually compile and it will work most of the time, but then one of a sudden just sec faults and boom, you have a security vulnerability. So I think in terms of generating that kind of code, LLMs are not quite there, but maybe they will get there. We'll see. But back to sort of EdgeDB, I think there is one invariant that if a language or a tool is easy for humans to understand and reason about, it must be easier for LLMs to understand, read about, and integrate with. And I don't want to sound too repetitive, but I know SQL pretty well, and for me, if I'm facing a SQL query that is like a couple of screens long, it will take me minutes to understand what it's even doing, and sometimes longer than that, and sometimes I would have a wrong impression of that. And I know that lots and lots of companies tried fine-tuning different models to sort of implement this text-to-SQL pipeline, and obviously there is a lot of SQL in the wild to sort of train those models on. And the results are still quite suboptimal. Maybe it will be solved soon, given enough progress in LLMs. Maybe not, hard to say, but we are thinking in my company that we should try that as well with HQL. And maybe, just maybe, HQL will be a more interesting target for an LLM to generate queries with. And if that's true, well, then that would perfectly sort of position EdgeDB for LLM-driven development, if I can say that.
Yeah.
Still, something that needs to be proved, but I'm fairly confident that that there is a lot of potential here. But second thing is, imagine that your prompt generates you an application, and that application has backend code and it has database schema in it and queries and everything else. Just as you said, yes, you need to inspect that code. You need to make sure that it's working fine. It might be less of a requirement for a hobby project, but if LLMs actually succeed in generating code, that would mean that they would also succeed at generating business applications, like enterprises and Fortune 500 companies. They're looking at this.
Yeah,
they want to adopt this technology for all obvious reasons. That means that they become more efficient. They can ship things faster. But that also means that they have to have enough tools to make sure that whatever LLM generated is sort of decent. They need to make sure that their staff and that their engineers can actually review it and reason about its complexity. And I'm not even talking about generating the first version of application. That could be easy, but imagine that relatively easy. But imagine that you also need to support this application potentially, maybe years into the future. And if it was generated by an LLM, I would assume that you would probably continue to use those LLMs. And imagine that you give it a prompt, hey, like add that screen for whatever kind of data entry. LLM spits out a bunch of code. You need to sort of commit it to your repository. You need to deploy it. You need to support it. You need to be on the phone with your customers for whom suddenly a new bug surfaced somewhere in potential unrelated part of the application. This is very complicated, and complex applications can have millions of lines of code. So, but even for small ones, it can be really, really hard to reason about the entire system. So as LLMs become more and more capable, we also need to make sure that that we have enough tools to understand what they're doing and sort of introspect that and reason about that. And in that context, I think it's incredibly important that whatever code is spit out by an LLM can be understood quickly by humans as well. So when people ask me, hey, like maybe databases will become completely irrelevant soon, like whatever, who cares how the AI would store data? Maybe they will reinvent the database for every application that they're building. Doesn't matter. I would say no, it still matters, because for probably foreseeable future, we will still be interacting with those systems. There will be software engineers that would interact with those systems, reviewing those systems and making sure that the direction is right, and stuff like that. So I'm all for this big emerging cooperation between the machines and the humans and in writing software. I think it's a tool, it's a force multiplier. But I just until we have AGI, essentially, then obviously all of our problems will be solved for good. But until then, we need to be able to still understand what the machine is doing, what the machine is giving us. We will still need to change the code, maintain that code sometimes ourselves, and that means that the progress in software engineering has to continue. We will invent new programming languages. We will invent new databases, new query languages. All of that will continue to happen despite progress in LLMs.
This gives me an interesting idea. A lot of people are talking about what is the next programming language, like Python. Well, they say it's English, but maybe just like you did with Edge, the programming language that you guys built for EdgeDB, maybe there's another programming language out there that's another in between the LLMs and English. Maybe there's another abstraction layer that can essentially make the machine even more readable than Python is, although Python's pretty good in terms of its readability. That's an interesting kind of thing that I'm gonna have to think on.
I think there is a precedent of that. That's legal English, which is
of course,
incomprehensible for for regular humans. It's incredibly precise, it's incredibly verbose,
Yes.
but it's definitely not terse or easy to review. And obviously there is like a lot of leeway in terms of still making it ambiguous.
Oh,
So
interesting.
I'm not sure that there is. I think the whole sort of idea behind LLM-driven development and not just development, pretty much anything, is that the machine understands the intent of
Yeah.
your
Yeah.
question or your ask and sort of guesses how it needs to fill the gaps. And this guessing part is always going to be imprecise. If you want it to be precise, well, just pick up Python and write your code yourself. If you want help from LLM, well, you need to give it some leeway. You need to allow it to hallucinate and then and help you a little bit, defining what you actually want. So in terms of programming languages and uh, um, how readable or expressive they are or easy they are, I think Python is pretty close to being a programming language that on the one hand, super precise and allows you to implement system pretty much of any complexity, and be easy to read and navigate through. And we have specialized programming languages for lower level stuff like Rust and Zig and C and Go and everything else in between. Um, but
So
yeah,
it's so hard to predict where this is all going. It's hard to predict where it was going 20 or 30 years ago, but now it's really hard to predict where this is going. And what you just said made me think that it's not a new programming language. It's not a new abstraction on the programming language. It's actually like a legalese type of language that works really well with LLMs, so that our natural English is not actually the best way to get with these LLMs. And this reminds me of the new thing with the GPT-01 model, which you don't need chain of thought prompting with the 01 model. That some people think that that's what they did, is they just built the chain of thought into it and then released a new API that charges a lot more money for the chain of thought to be built into it itself. But it doesn't seem, it could just be. And so with a chain of thought, with the old school LLMs like GPT-4 or Sonnet, you actually want to be really funky with your language. Like we had a guy who presented at our AI Whisperers meetup, and he's a non-technical marketer who latched on very quickly to LLMs and has figured out a bunch of stuff that I've been trying to figure out, of how to get the AI to code for me to build not the embedded systems, but to just build simple websites, web development. And so he showed us his method. His method of the language that he used was totally out of the world, like just like summoning people, magical, as much kind of whimsical, like crazy adjectives that you could get into it would do exactly what you said about how to make it hallucinate more, how to be creative for you, so it could solve creative problems. It's such a strange world we're entering.
yeah. For what it's worth, I think it's just a limitation of the current systems. I think they will evolve.
Yep.
I don't think that the future of LLMs is interfacing with them, interacting with them using legalese, but rather the future of them is probably them gaining enough capacity to really understand your business requirements and really understand complex code bases, which means huge context windows and the ability for them to reason. Maybe this latest OpenAI development and the chains of thoughts is the step in the right direction for something like this. I don't know, but I think the whole idea here is just you say a few things and it just guesses correctly what it needs to do. But all in all, you will still, at the end of the day, will have to review that code, and if your business depends on it, you gotta be sure that you are not blindly pressing the green button, deploy to production. That you still understand what it actually did.
Yeah, that's a great point. So it's like a reading and writing. You can write to it, but our ability to read and to take in what the LLM is doing is really important. This reminds me of an app that it feels like I'm like my next app that I want to build is going to be specific to me doing exactly that, because now what I'm doing is I'm deploying these applications one-off where I'm just going through it to get used to the code base, to get used to these structures and everything like that. But the next step for me really is to pick one and build it out and get comfortable with what I've already gotten it created and to understand what's going on. And it feels like the main piece that I'm really struggling with is figuring out which files relate to other files and which folders are dependent on which other folders. And so I'm now getting Claude to create the artifacts for me that will help me to visualize it. So it goes in and creates mermaid code and shows me my application. And so I think the next thing will be developing sort of like a free code camp, the way that free code camp works, which actually tests you on your knowledge and tells you to do, it prompts you to do something in the same way we prompt the LLM so that you understand it and you code, and it's got unit tests on the back end to make sure that that code does what it's supposed to do. And so I'm thinking somewhere along those lines of like, okay, here I've got this code base, and then sort of like a free code camp, not for learning how to program, but learning the connections between the databases and such. Mm-hmm. So that feels like a good project, but I have to do a lot more thinking on it to understand. Any thoughts on that? I've got a few more questions in the last 10 minutes or so where we can kind of go into other things, but if you have any thoughts, I'd love to hear.
No, just a few random thoughts that I had on this. First, I think it's important to keep in mind that LLMs are a tool, still a tool, that this is not magical oracle that can give you the end product. You have to use the tool, and it's a great tool. It's a great force multiplier. You still have to understand what it does. Second, I read this random tweet some time ago, and it resonated with me. I don't remember who wrote it, but it was that this is a force multiplier. So someone who generates, if a non-artist generates an image with LLM versus when a true artist uses LLM to generate an image, the results are going to be drastically different, even if the LLM is the same. I think there are some parallels with software engineering as well. Like if you are a software engineer, a good one, then you'll be able to use LLMs and different AI coding tools to a bigger advantage. So I think it's still important to understand the fundamentals. And the third one is that I think all those tools, AI tools, will actually help teach people faster, which is also important. It's kind of funny. So basically, I think what in the end will happen is that they will be able to take a junior engineer and sort of help them advance faster to a senior engineer, so that the senior engineer can control the output of of those tools better. It's like a closed loop. But I know a lot of use cases where, for example, you need to write some code that uses relatively popular library that you don't know much about, and you start prompting LLM. LLM gives you enough boilerplate for you to go through the documentation and figure out how it works. And then you can potentially do some adjustments and whatnot. But it's a great entry point. Instead of doing this process yourself, which is typically opening up documentation for a new library and browsing it for about a day or a few hours to understand the general layout of the API, of the data flow, of all of those things. Instead, you basically compress all of that into a single prompt. Hey, give me the first iteration for this kind of problem. It does, and then you learn in sort of reverse order. But that's going to be faster for you. So that is incredible. I think I would never imagine that this would happen 10 years ago.
Yeah. That took all of us by so much surprise, except for the few people who got onto GPT 2.0 and now understand why they saw what they saw. Although a lot of them are among the doomers, which I find very interesting. A lot of the people who discovered GPT 2.0 ended up being on the doomer side, which is like, I don't see it, at least for now or in the next 10 years. I don't see the doomer side so far. It's just been able to help me code much faster. So the junior developers is a very interesting thing. It's something that I've been trying to figure out on my own end, and it's so interesting right now because so many companies, particularly the big tech companies, which in the high interest or the low interest rate era, were doing the most hiring of tech people And now they've slowed down with what happened. And also we have AI now changing it. So it seems like there's a lot of senior developers who can use LLMs as a junior developer, and they don't need to hire the junior developer. At some point, it's going to shift that it feels like they're going to start hiring once we kind of figure out what you said about how to turn the junior developer and create all the tooling so that the senior developer can just kind of easily see what the junior developer has done and get them up to speed much easier. What's your take on this? Have you hired any junior developers recently? It doesn't, I mean, I understand that there's like companies that are different scales, and this feels like a company that is maybe at 400 or 500 people. That's where they would start needing to hire junior developers to bring them in. What's your take on this? How do junior developers even become senior developers as of now? Is it just, do we have to wait until this settles out? Because it feels really hard to be a junior developer at this moment and get a job.
Uh, I I'm not 100% sure what's going on with the job market right now for junior developers and whatnot. But I mean, everybody was junior at some point of
Yeah.
time. I was junior. I hope that I'm senior now. But all it takes is time, work time, debugging time, experience. All those hours will ultimately manifest in experience, and that experience will be what qualifies you as a senior developer. I think hiring junior developers is important for multiple different reasons. One of them is diversity, and by diversity I mean diversity is important for like in many different manifestations of it. One of them is technical expertise, because sometimes, like in an ideal world, you don't want technical people to just care about the code. You also want them to care about the product and whatnot.
That's right.
And basically, when you have diverse team, multiple different things happen. First of all, new people come and they see the actual product from different side. They might ask
Yeah, interesting.
what seems like a stupid question in the beginning, but that stupid question can potentially lead to a big change or refactoring of the system. If new people join and they have trouble understanding the system, even if they're junior, maybe your system is wrong. Maybe you don't have enough documentation. So that forces companies to create better documentation and internal tooling and improve upon it, which actually makes senior engineers more productive. Then the whole thing of mentoring people and culture around that, the culture around maintaining code reviews and making sure that you're not blindly accepting them, that you actually do reviews. So from the cultural standpoint, I think the diversity in expertise, just like as diversity in anything, but diversity in expertise is also very, very important. So I think that big companies recognize that, and they also know that there is a lot of benefit in taking someone relatively fresh with regards to their career and growing them internally, because during that growth, again, they will contribute a lot, but ultimately, if they decide to stay with the company for a longer term, it's going to be hugely beneficial for the company. So yeah, there are multiple different aspects to this, and obviously, not everything is about raw efficiency of you as a coding machine.
Yeah, that's a really good point. So now my understanding of how to make someone professionally more attractive first is to learn how to use these LLMs, no matter what role that they're in, because that does seem like a very important thing professionally. But now what you just said made me reorient my understanding, because it's not just the technical part of the company, because the technical part of the company always supports the business, and the business is always dealing with selling to other people or other businesses, and the product that is sold. And so it makes me understand that the primary thing that one would want to do in terms to thrive in the upcoming acceleration is to essentially get more world experience. So get more experience doing things that really matter, rather than the sort of weird thing we've had for some time is the performative acting, as if we're doing real stuff, but not actually doing real stuff, which is quite common in the world. But there's this other, like going and figuring out how the way things really work and the holistic understanding of placing the job that we're doing in the context of the entire thing that we're trying to do. So really brilliant. What is next for EdgeDB? What are you guys working on now? What are your what are the milestones that you're looking to hit, and what's the plan?
We're still relatively early as a company. We raised our Series A almost exactly 2 years ago, and we released the first version of EdgeDB just 2.5 years ago. So we're still relatively early. So what's next for us is growth. And in the more immediate future, we are about to release a new version of EdgeDB in a month or two. One of the features, surprisingly, is going to be support for SQL. So essentially, we want to lower the learning curve of EdgeDB and allow people to use the tools that they want to use. So right now, the value proposition is that, hey, EdgeDB is this amazing new relational database with a new query language, new data model. It solves so many different problems and will make your software development easier. But at the end of the day, the learning curve is still relatively high. You have to install a completely new database product. You have to learn new query language. You have to learn new data model. And we just want to lower the learning curve to make sure that you can get productive faster, as fast as you can. There are a bunch of other different improvements to the UI, to the cloud product. We are adding geospatial types to EdgeDB. Improving operational sort of characteristics of that, like in place upgrades of the database version and whatnot. So the downtime is incredibly slim. Things like that. But mostly it's continuing to figure out what people want, how we can make their lives easier with EdgeDB, and improving the product. And on the other hand, we also want to experiment with AI a little bit further. We do have AI capabilities in EdgeDB. So for example, in your schema, you can say, hey, I want OpenAI or Anthropic or Mistral to index this specific data and create embeddings for it. And then EdgeDB would do that for you fully automatically. You don't need to write any code.
Oh, wow.
Just do it. And it will give you a RAG endpoint, so you don't need to implement RAG by hand. EdgeDB will just do the whole thing for you automatically, fully automatically. So we already have a lot of interesting AI capabilities in the product right now, which I think are pretty cutting edge. But if we can crack this problem of text to SQL, that could basically make EdgeDB a rather unique database product in the AI landscape, like where you can ask the database a complex question. It will turn that question into a query that you can actually introspect and like see that it's correct, fetch the data, feed the data back to LLM, and then LLM will answer the remainder of the question. That would be the dream. And imagine if you had a button, save this as an API call, and boom, you have an API that can accept JSON and give you the output. That would be cool. But again, a lot of stuff needs to be built for that. We'll start exploring soon.
Beautiful. Thank you so much. And how can people find you or your company on Twitter or anywhere else online?
So you can find me on Twitter. My nickname there is 1st1, just 4 characters, first one. And EdgeDB on Twitter is EdgeDB's, without any ASCII characters in between, just EdgeDB's.
Cool. Thank you so much.